What am I saying here? From negative infinity to 2, 2, not 2 to infinity. Well, this means all real numbers. There is nothing missing. All numbers to the left of 2 are in the domain. 2 is in the domain, and everything after 2 is in the domain. So the domain is all real numbers. Do we all agree with all real numbers? Okay, perfect. I will start a table, very important table, in which the first row is values of the independent variable, and the second row is the values of the dependent variable. I must put this value of 2 in the table, and also 0. So 0 is always in the table, 2 is always in the table, 2 is in the table for this function. Notice something very important. There is a bracket to the left of 2, and there is a parenthesis facing right of 2. I will put these symbols touching each other exactly under 2. Not to the left, not to the right, under 2. So I have a bracket facing left and a parenthesis touching the bracket facing right. I also make myself another note here. The note is that between negative infinity and 2, I must use the function 2x minus 4. Another note to myself, between 2 and infinity, I must use a different function, which is x plus 1. I chose very simple functions. They are linear functions. And for linear functions, I hope we remember, we need 2 points. When I plug in 0 here, what do I get? When x is 0, how much is the y value?
-4.
Excellent. Thank you very much. When I have x equals 2, what do I get here? And I put the number right inside the bracket. Not in front of it, not to the right or left, just inside. When you plug in 2, what do you get? Two times 2 minus 4. What do we get?
0.
Very good. Awesome. Now, on the other side, I know you're going to say, you cannot plug in 2 in here because 2 does not have the equal symbol, and you cannot have the equal symbol in both because that will not be a function. So you're going to say, I'm going to say, please evaluate for 2, and you're going to say, no, I refuse. And you are correct. You should refuse to evaluate this function at 2. Because I have to evaluate this piece at 2, not this piece at 2. But I am going to answer in this way. If you do not, which you are correct, if you do not agree to plug in 2 here, then you will have to plug in 2.000000000000001. Do you want to do that? No, you don't want to do that. So then I will insist that you plug in 2 and tell me what you get. And I'll tell you what happens. And I will put the number right here inside parentheses. So when we force a 2 in here, what answer do we get?
You get 3.
Good. I need another number because it's a linear function, so we need 2 points. So I'm going to look at 3. So when you plug in 3, what do you get?
4.
That's it. Excellent. Now, So what's the difference between these two? It's huge, huge difference. This point will be a full point, but the other one will not, because I forced the 2 in there and I was not allowed to. So this one will be an open point because I'm not allowed to plug in 2. I did it because I didn't want to plug something like this. How will I even plot something like this? So I forced the 2, although I wasn't allowed to, but in that case, it has to be an open point. An open point is this, a full point is this. In other words, this one doesn't really exist. It starts immediately very close to it. That's all we need. Now the table will tell me how to graph this function. Let me say this from the very beginning. If somebody graphs something like this, I will say that the student did not pay attention to what I said in class. This is not a function by the vertical line test. So you cannot ever allow the 2 branches to overlap. That's number 1. Number 2, this function is allowed only to show only between -infinity and 2, nowhere else. This function will only show between 2 and infinity and nowhere else. That's why I reinforced with these braces. So I'm never ever tempted to extend this function to the other side or this function to the other side. Because if I graph something like this, this is not a function by the vertical line test. Okay, so therefore we are ready now to graph it. Okay, so I plot 0 for x, -4 for y. I plot 2 for x, 0 for y. It's a full point. I finish the left branch. You do not have to use colors. I will, to make a point. The next point is 2, 3. But it is an open point. Because by the vertical line test here, if I have 2 full points, the graph is not a function. And then I have 3, 4. And here it is. If I extend again, second time please, if I extend this to the left and I extend this to the right, oops, this is no longer a function. The orange piece is only from 2 to infinity. The black piece is only from -infinity to 2. Now this is a function by the vertical line test. Every vertical line crosses the graph in only one point. Even if I want to graph a vertical line here, that's fine. It only crosses in one point. Now, the problem may also ask me to find the range. Yes, we will review range again in R. That can anyone give us the range based on the graph? So remember, one more time, domain. This is the graph. It continues forever, and it continues forever, but not this way. So I realize that the domain is all real numbers because every vertical line everywhere from -infinity to +infinity will cross the function in one point. To find the range, I have to imagine that I draw horizontal lines everywhere through the graph. It hits the graph, yes, negative infinity. Yes, 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 yes. -3, -2, -1, 0. Yes. Gap. Nothing, nothing, nothing till it gets to 3, but 3 is not on the graph. But everything else is. Can anyone try to give us the range of this function?
So would it be parentheses, negative infinity, comma 0,
Excellent.
parentheses,
Not parentheses. Oh, sorry. But bracket, because it's a full point.
oh, right,
A
bracket,
full point, yes.
and
Union.
then parentheses,
Yes.
3,
Yes. All the
to
way to
infinity.
excellent. Excellent. Thank you, George. Thank you. Great. That's it. So we could not include, so this is the union symbol, which means the range is here or here. They have to be put together. Okay, any questions? Any questions? Okay, so this is a big chunk of the review anyway. We basically started R.1, but now I'm going to start from the beginning. So review, and we're going to start with R.1. And R.1 deals with basically just functions, graphs, equations, very simple review. So I'm going to open the book, and I'm going to let you choose. Okay. So on page, actually 10 first. Okay. So I'd like to choose a linear equation and show you how to graph a linear equation using x and y intercepts. So there is no need to look at the quadratics and cubics because we're going to review those later. But I'd like at least something like 9 or 10 to review on how to graph a linear function or a linear equation using x and y intercepts. Okay, I will choose 9. So this is 9 on page 10. And we have 6x plus 3y equals -9. So just to graph such a function or equation, same thing. The most important points are always the x and y intercepts. And a quick review. So this line is a position line. This line is a position line. Position, position, position. This line is altitude. -5, -2, 0, 1, 10. This is position. -5, -3, -2, 0, 1, 2, 5. So a vertical line only has x in the equation. A horizontal line has only y. So the vertical line, something like this is x equals -3. This one is x equals 0. This one is x equals 7. So these are so-called position. Now when we talk about horizontal lines, we talk about altitude. So let's say this one is y equals -3, and let's say this one is y equals 4. And of course this one is y equals 0. And this is what I wanted to refresh your memory on. I wanted to refresh your memory on the fact that the x-axis has the equation y equals 0, and the y-axis has the equation x equals 0. And this is what we need in order to determine the x and y intercepts. So if I'm trying to find the y-intercept, I set x equal to 0. If I'm trying to find the x-intercept, I set y equal to 0. Why? Because that's the equation of the x-axis. And this is the equation of the y-axis. Because it's position, vertical, only x, altitude, only y. So here, the simplest thing to do is set x equal to 0. Negative 3y equals negative 9. How much is y? As you notice, I just covered it because x is 0. And I have positive 3y equals negative 9. How much is y?
Negative 3.
That's it. Right here, right now, I have to write the ordered pair. I cannot continue because I may mix them up and who knows what I'm coming up with. Right here, I have to write the ordered pair. What is the ordered pair? Remember, x is always first, y is always second. Coordinate.
0, negative 3.
That's it. Now I want to find the x-intercept. 6y equals negative 9. I simplify by 3 and I get that x equals negative 3 halves. So then the ordered pair now is negative 3 halves or negative 1.5 comma 0. So again, what did I just do? I said when x is 0, I got y equals negative 3. And I wrote the ordered pair. Then I said, okay, what happens when y is 0? Then I have 6x equals negative 9. I divide it by 3. And then I have negative 3 halves. Always x is first. Always y is the second coordinate. So I found the ordered pairs. That's all I need. And I will connect and extend the line. And you can say, you just showed us that every time you graph a function, you have to write the domain. True. But not for a linear equation or linear function. That's the easiest on the planet. There is nothing easier than this. So I have 0 for x, negative 3 for y, negative 1.5 for x, 0 for y. I connect and extend the line. This is the only one that is acceptable as is. We always have to write the name of the equation or function we graphed next to it anywhere you want. So this is what I graphed. Domain and range, all real numbers, of course. Any questions? I wanted to talk about the compound interest. I know I only have 2 minutes. I just want to mention the formula and we'll work on it next time. Compound interest formula. Compounded interest formula. So this is the accumulated value equals the principal 1 plus the annual interest rate R over n, the number of times the interest is compounded, and n times t. So A, accumulated value. P P, principal. R, annual interest rate. T, time in years. And N, the number of times the interest is recalculated per year. Number of times interest is recalculated or compounded per year. Sorry, I ran out of time, so we don't have time to